Chapter 8, Lesson 6, Changes in Dimensions. You will be able to solve problems involving similar solids. If solid X is similar to solid Y by a scale factor, then the surface area of X is equal to the surface area of Y times the square of the scale factor. So in other words, the surface area of the new figure equals the surface area of the old figure times the scale factor squared. The surface area of a rectangular prism is 78 square centimeters. What is the surface area of a similar prism that is 3 times as large? This 3 right here represents our scale factor, and this is our old surface area. So to find our new surface area, I'll just put an N for new, it equals our old surface area, O for old, times our scale factor squared. So the surface area of the new equals 78 times 3 squared. Plug it in, and you get your new surface area of 702 square centimeters. Letter B. The surface area of a triangular prism is 34 square inches. This is the old one. What is the surface area of a similar prism that is twice as large? That's our scale factor. So surface area of new figure equals surface area of old times scale factor squared. Surface area of new equals 34 times 2 squared, which means our new surface area is 136 square inches. The world's largest box of raisins has a surface area of 352 square feet. If a similar box is smaller than the largest box by a scale factor of 1/48, what is the surface area? Round to the nearest hundredth. So this is our scale factor here, 1/48. And this would be our old surface area. So surface area of the new figure equals our old surface area times our scale factor squared. The surface area of the new figure equals 352 times 1/48 squared. Plug it in your calculator. Make sure you put 1/48 in parentheses. And we would get 0.1527 repeating. To the nearest hundredths place is where the 5 is. So the surface area would be 0.15 square feet. Letter D. The dimensions of a rectangular prism are 1 inch by 7 inches by 5 inches. So we'll call this length, width, and height. What is the surface area of a similar solid that has been enlarged by a scale factor of 7? Now, we don't have the surface area. We need to find the surface area. If you recall, the surface area of a rectangular prism is 2 times length times width, plus 2 times length times height, plus 2 times width times height, which is 2 times 1 times 7, plus 2 times 1 times 5, plus 2 times 7 times 5. Plug it in, and this is all our old surface area. The old surface area is equal to 94 square inches. Now we have our old surface area and our scale factor. So we can use our other formula here. Surface area of new is surface area of old times scale factor squared. So our surface area is 94 times 7 squared, which equals 4,606 square inches. Now with volume, if solid X is similar to solid Y by a scale factor, then the volume of X is equal to the volume of Y times the cube of the scale factor. Now, volume is cubic, therefore scale factor cube. Before we were dealing with area, and area is squared, that's why we squared our scale factor. So volume of new equals volume of old times scale factor cubed. A triangular prism has a volume of 432 cubic yards. This will be our old volume. If the prism is reduced to 1/3 its original size, what is the volume of the new prism? So 1/3 is our scale factor. Volume of new equals volume of old times our scale factor cubed, because volume is cubic. Volume of new equals 432 times 1/3 cubed. Make sure 1/3 goes in parentheses. And we get a nice even 16, and it will be yard cubed. Letter B. A square pyramid has a volume of 512 cubic centimeters. That's our old volume. What is the volume of a square pyramid with dimensions 1/4 of the original? 1/4 is the scale factor. Volume of new is volume of old times scale factor cubed. Volume of new equals 512 times 1/4 cubed. Volume of new equals 8 centimeters cubed. Letter C. A cylinder has a volume of 459 cubic meters. What is the volume of a cylinder with dimensions 1/3 of the original? Volume of new equals volume of old times scale factor cubed. Volume of new equals 459 times 1/3 cubed. Our new volume is 17 cubic meters. Letter D. A sink with a sliding lid in Josh's art studio measures 16 inches by 15 inches by 6 inches. The second sink used for just for paintbrushes has a similar shape and is similar by a scale factor of 1/2. Find the volume and surface area of the second sink. So here we have a multi-step problem. We are going to need quite a bit of room. First thing we need to do is figure out the surface area and volume. Well, volume, it's rectangular, is length times width times height. And this will be the volume of the old figure. So we'll call 16 our length, 15 our width, and 6 our height. So 16 times 15 times 6. Our old volume is 1,440 cubic inches. We also need to find our old surface area. So surface area is 2LW plus 2LH plus 2WH. Surface area equals 2 times 16 times 15 plus 2 times 16 times 6 plus 2 times 15 is our width, and our height is 6. Let me move this over. It's a little difficult to see. We'll just rewrite this piece. Okay. This is 15, and this was 6. There we go. So the surface area is 852 inches squared. Okay. So let's find the volume of our new figure. The volume of our new figure is the volume of the old times the scale factor cubed. Volume of new. The old volume we found to be 1,440. Our scale factor is 1/2. Plug it in, and we get our new volume of 180 cubic inches. And our new surface area is our old surface area times our scale factor squared, because it's area. So our old surface area is 852. Our scale factor is still 1/2, but we're only squaring it this time. And we get 213 inches squared. So the new surface area and the new volume are 213 and 180.